Now students, see, this is the experimental setup for determination of unknown resistance using meter bridge. See, this is the source, the red is the positive connected to the point A according to our board diagram, and the negative is connected with the B. In the left gap there is a resistance box, in the right gap there is an unknown resistance, between the middle point and jockey there is a galvanometer. Now what is the process? After giving some resistance from the box, switching the switch on the circuit and slide the jockey from the end A to B, and see at what point, suppose this is the point when the galvanometer gives zero deflection, means this is the balancing conditions. Now you have to check from on the scale the what is the balancing length, means the length from the left end to this point is the balancing length, that is the value of L, and this one is 100 minus L. So these two things and the R which you provided from the box is required to determine the unknown resistance. Okay. Now student, this is the experimental setup to compare the EMF of these two cells using this potentiometer. Now this is A end and this is B end. So according to our connections, at the end A we connect the three positive, thus driving cell positives and two driven cells positives. See, all these three positives are connected to the point A. Now the negative terminal is connected with the rheostat, from rheostat to the negative of ammeter, from positive of ammeter to the end B. Clear? Now the negative of these two driven cell connected with the two end terminal of a two-way key. From middle point we connect the galvanometer, from galvanometer to jockey. So what is the experimental process? First we have to give some current in the circuit and you have to note the current from the ammeter. In that situation, first you have to connect one cell, suppose this one, and you consider this is A1. For that you have to find out the null point over the potentiometer where. Suppose by touching here you got the balancing conditions, means null point for this cell, means through the galvanometer no current is passes. So how can you measure this length which is actually L1 according to our formula? Now see, before this point how many wire are there? 1, 2, 3, 4, means 400 centimeters. Okay, after 400 centimeters the fifth wire is started from here, means you have to take from here to here. So means 400 and up to this I can see here 66, means 466 centimeter is the value of L1. Now you have to open this one and you have to connect E2. By the same process again you have to touch the jockey terminal over the potentiometer wire to determine the balancing conditions for the cell E2. Suppose now you got here the balancing length, for example. Before that there are two wires 200 centimeters and the third wire is started from here and this one is 71. So therefore 271 is the value of L2. So after determining the value of L1 and L2 by using the working formula E1 by E2 equal L1 by L2, we can easily compare the EMF of these two given cells using this potentiometer. Now student, this is the experimental setup to determine the galvanometer resistance and to determine the figure of merit. Now see, what is the connections? Source positive to resistance box to galvanometer, galvanometer to source negative. Okay, and with the galvanometer we have to connect a shunt resistance in parallel via a key. Clear? Just see, from galvanometer to this to this, means this shunt resistance connected in parallel with the galvanometer via a key. Clear? Now initially what is the process actually you have to know? Initially this shunt is not connected in the circuit. Then we have to apply some resistance from this high resistance box, for which we get the maximum deflections in the galvanometer, say 30 division, which is the value of theta. Now whenever you close this key, means shunt is connected, then you see that the deflection of the galvanometer becomes 0. Now you have to give some shunt resistance such a way that the deflection of the galvanometer becomes 15, which is exactly half the previous maximum value. That's why this process is called half deflection method. So therefore the resistance which you provided from here, that is the value of R, and the resistance which you provided from this box, that is the value of S. So therefore by using the formula G equal Rs by R minus S, we can determine the resistance of this galvanometer. Now student, whenever you want to determine the figure of merit, you just totally remove these portions. Only these portions is required. Clear? Now you have to give some resistance and you have to determine, you have to check the deflections of the galvanometer and the EMF which you provide in the circuit. Because for the figure of merit, the working formula is K equal E by R plus G into theta. So E be the EMF of this cell, R be the resistance which you provide from the resistance box, G be the resistance of the galvanometer which we already determined from the previous explanation, and theta be the deflection of the galvanometer. So therefore by using this formula we can determine the figure of merit. Thank you students.